ellipse, can you see that if I write it in pencil? Can everybody see that? Okay. An ellipse is a locus of points such that the sum of the distance from any point to the ellipse remains constant. Here's what an ellipse looks like. There's two shapes. There's horizontal and there's vertical. We'll talk about these in a second. But an ellipse kind of looks like an oval, right? It's not circular. It can be close to a circle, but it's not going to be circular. You have two fixed points called foci. It's important because you will have to find your foci. You'll have to find the exact value of them. Okay? And then, so your foci are here. And then we also see this D1 and D2. The big thing here is those distances added together, no matter where your D's are, have to remain the same. We won't focus on that little D1 and that little D2 very much because these are what you're going to need to be able to graph them. Okay? You're going to have to find, every single time you'll have to find those 5 things. Length, center, vertices, co-vertices. Major axis. It's your longer axis. Now, if I'm looking up here, don't do this to yours, look at mine. Do you notice how there's 2 axes? They run both ways. Clearly one is longer than the other, right? So if I label this one line 1 and this one line 2, which one's my major? Line 1. Now, notice what happens in line 1. What did I draw line 1 through? The foci. Both foci are on there. Are the foci on line 2? No, the foci are always going to be on your longer axis of symmetry is what I should have written because it cuts it in half. And it has to contain both foci. That's important. Okay? That's your major axis. Your minor axis is your smaller axis of symmetry. Are the foci ever going to be on my minor? The answer to that is never. Okay? They're always going to be on my major, never on my minor. Okay? The center. Can you tell where the center is on that ellipse? It's exactly right. It's right here. Okay? Your center is your point where your major and minor axis intersect. It's where they intersect. Okay? Are we cool with me there? Now we have vertices and co-vertices. Vertices are your endpoints. What do I mean by endpoints? Like right where they end, right? So where my segment stops. This is the endpoints of my major axis. And the co-vertices are the endpoints of your minor axis. We cool there? Everybody cool? We have 2 versions of ellipse. You're going to hear me ask you this. This is exactly how I'm going to ask it. I'm going to say, does it stretch horizontally or does it stretch vertically? Does that make sense? So if I tell you, does it stretch horizontally, that means your major axis is going to be horizontal. Does it stretch vertically? Your major axis is going to be vertical. Now, you're going to want to label what these things are. So this point right here, what is that? That's the center. And over here, it's right there. That's your center. What do you think that is? Hold on, it's coming. What do you think that is? That's a foci. Same with that. Okay. What about this one? Which one though? There's two sets. Well, which we call a vertex. Vertices is multiple. We call this a vertex. Which also happens right there, correct? You guys follow my arrows? I'm just did them on one. Okay. What's this thing called right here? Right here. Huh? That's a foci. And this is a vertex. This is what? That's a covertex. As well as that. So when you graph these, you could have upwards of 7 points, but a minimum of 5. Make sure you understand that because I'm going to be expecting it. You'll either have 5 points you have to graph or 7. Sometimes you can't graph the foci. Sometimes they're not pretty. Are you listening to me or not? If you can't graph the foci, if they're not pretty, then you're going to know when you can and when you cannot. Now, you have to know how to graph them. So, to graph the vertices, they are plus or minus a units away from the center because you have one on the left and one on the right, or one up and one down. But the a is important. They are a plus or minus a units away. The covertices are plus or minus b units away from the center. If I ask you for a length, your length of your major axis is 2a, and your length of your minor axis is 2b. And the foci are plus or minus c units away from the center. Okay, now notice here, I have a formula to find c, and then I have a standard form. To find c, you will always use this. C squared equals a squared minus b squared. But you're going to need to find c. How do I find c? You just take the square root of it. And don't forget, you're going to need a plus or minus on there. Because again, there's two foci. Okay, now there's two different formulas you need for an ellipse. You need a horizontal one and you need a vertical one. Okay, I'm going to put the horizontal on the left. I'm going to put the vertical on the right. Let me write them down, and then I'm going to have you guys look at what the differences are and see what changes, okay? So your horizontal will look like this. So write those down for me really quick, please. Okay? What do you notice about these two equations? What? Well, A and B are switched because A has to be the major. Okay? If A is the major, it's underneath the X, which means it's pulling this way. If A is under the Y, it means it's pulling that way. There's something else you have to know. You will have to know that. Which way is it stretching? You'll have to know. There's something else that's very important. This is imperative that you guys figure this out. And by staring at me, it's not going to help. Look at your equations. They have to equal 1. They're not always going to equal 1. They have to equal 1. All right. I want to get at least one graph done. So here we go. We're going to do the one on the left. Does it stretch vertically or horizontally?
Horizontal.
How do you know?
Because the bottom bit, the first one's bigger than the second.
Right? 64 is bigger than 25. So it has to stretch horizontally. Okay? So soon as I make sure, is it in standard form so does it equal 1? Yes. The next thing I immediately do is I write that because I'm going to need A, B, and C. Well, what does A squared equal? What does A squared equal? 64. What does A equal? A equals 8. Sometimes you need the squared, so don't get all crazy. What does B squared equal? 25. So B equals 5. To find C, you're going to take the square root of A squared minus B squared. Do not put 8 and 5 in there. I've seen it. Don't do it. What's 64 minus 25? I'll help you. It's 39. It's 39. Can 39 be simplified? Well, it's 3 and 13, but 3 and 13 are both prime. Okay, so it can't be done. Once you have these, you start figuring out what you have here. Where's my center? What's H and K? It's the same thing as a circle. What's H and what's K? What's H here? 0. What's K? 0. So my center is at 0, 0. It's just like that circle, right? It's what we did yesterday. Now, here's where you got to listen. Which way is this stretching? Horizontally or vertically? Horizontally. So the vertices are going to change the X values, not the Y. Does that make sense? Because it's stretching this way. Because it says over here, the vertices are plus or minus A units away from the center. So you have to know that this stretches horizontally, and your horizontal is your X. Okay? So that means I take my A value and I add it to my X coordinate of my center, and I subtract it from my X coordinate of my center. So if I add 8, you get 8 comma 0, correct? And if I subtract 8, you get negative 8, 0. Does that make sense? Because it's stretching this way. The co-vertices go with B. B is 5 though, right? Co-vertices go with the other coordinate. Since I changed my X for my vertices, that means I'm going to change my Y for my co-vertices. So I'm going to add 5. And I'm going to subtract 5 from the Y value. Where do the foci, what do the foci go with? Which axis are the foci on? The major, which is which direction? It's horizontal, right? So horizontal means it is either X or Y. Which one? It's x. So you take your c value and you add it to your x coordinate of your center. So your foci are going to be plus or minus radical 39, comma 0. Would I have you graph the foci? Why not? It's ugly. Could you graph the other pieces? 100%. You graph your center, your cos, and your vertices, and you draw it just like that. It's got to be egg-shaped. If it looks like a circle, I'm going to mark it wrong. I expect to see those 5 points on every single graph. If we can graph the vertex or the foci, we will. Okay? I'm not making you do anything for homework tonight. It means you're going to have homework tomorrow night. Okay? That is that. That's the first part of ellipses.